Lesson 2, analyzing quadratics. So quadratic equations can be written in a couple of different forms. We can write it as function notation of ax squared plus bx plus c, or we can write it in an equation form as y equals ax squared plus bx plus c. A, b, and c are real numbers, and the value of a can't be equal to 0. The reason why it can't be equal to 0 is because if this equals 0, this term equals 0, and I now have bx plus c, which is a linear equation. It's not a quadratic. So quadratic equations have a degree of 2. That's what makes them quadratic. They have a squared x value or a squared k value, m value. They're a degree of 2. A quadratic equation is when I let it equal 0. The roots of the equation are related to the zeros of the function, which are also related to the x-intercepts of the graph. So that was from yesterday. The roots, the zeros, and the intercepts are all interrelated. Just like in linear equations where we have the slope y-intercept form and then we have the general form, we have two different forms for our quadratic equations. We have this general form, which I've already showed you, and then we have this standard form, which could be written as f of x or y equals a times x minus p squared plus q. A, p, and q are real numbers, and again, a can't be equal to 0 because it would eliminate all of this stuff. This standard form is the form that we want. Standard form makes it easier for us to analyze what the quadratic looks like. In standard form, I can tell you if the quadratic opens up, I can tell you if it opens down, I can tell you if it's a wide parabola or a skinny parabola. I can tell you where it crosses the x-axis, if it even crosses the x-axis, and how many times it will cross the x-axis, all based on what the standard form is. So what we will look at is we will look at the characteristics of standard form, we will look at some of the characteristics of general form, and then we will look at how can I go between the two forms. How could I take general form and write it in standard form? Or how could I take standard form and write it in general? So if we start off with the equation y equals x squared. If x equals negative 3, what would y equal? If x equals negative 2.
4.
Negative 1?
1.
0?
0. 1. 4. 9.
So then when I go to graph this, I get this curve, which I can join these points together to give me this shape, which we call a parabola. If you notice, this parabola has a line of symmetry. It goes right down the middle. It splits the parabola in half. So what is this line of symmetry in this parabola? Where do I find it? It's the y-axis. So it's the y-axis, but as an equation, the y-axis is that x is equal to 0. That's the equation of the y-axis. Because every point on the y-axis, the value of x is always equal to 0. Okay, and if you remember from last year when we were doing our linear lines, vertical lines had an x equals equation, and horizontal lines were a y equals equation. Because in a horizontal line, the y value stays the same. In a vertical line, it's the x value that stayed the same. Then we have the vertex of a parabola. The vertex of the parabola occurs where the axis of symmetry, this is my axis of symmetry, intersects the parabola. Where did it intersect the parabola? At 0 and 0. So the coordinates of the axis, or of the vertex, which I can now label V, is 0 and 0. The vertex can be a minimum point or a maximum point depending if the graph opens up or down. In this case, is V a minimum point or a maximum point? So to answer that, ask yourself, is V the lowest point it'll get or the highest point? It's the lowest point, which makes it a minimum value. So the minimum value of the parabola would be the vertex in this case. So this is the minimum. And when we talk about the minimum value, we talk about the y-axis. So the smallest y value we get for this graph is at 0. I will never have negative y values. What's the domain of my parabola? What are my possible x values? Negative infinity to positive infinity. So that's putting it in interval notation. I can also use that set notation with the squiggly brackets, values of x, such that x is a real number. And it is important that you be able to go back and forth between these two types of representations. What are my possible y values for this parabola? What y values can I have? Or what y values can't I have? I can't have negative. So my y values always have to be greater than what value? 0. So in interval notation, I can go from 0 to infinity. Curved bracket on infinity, because infinity is a concept more than it is a number. But on 0, I would use a square bracket because it can equal 0. If I use my set notation, the set of y values such that y is greater than or equal to 0, and y would be a real number. So you could use either form to demonstrate this domain and range. So we're going to work through the next investigations. We won't get done the lesson today. We'll finish it up tomorrow. But we'll see where we get to with these investigations. The next 3 investigations help us explore some general transformations on the graph of my general parabola, this y equals x squared, to see what happens if I put in a q value, or a p value, or an a value. What does that do to the graph? If we can understand what those 3 letters do to the graph, it allows us to be able to sketch the graph without depending on our calculator all the time. So if I have the graph y equals x squared, that's this graph right here, it says write an equation which represents each of the following. This right here, when it says y equals f of x plus 3, well, f of x equals x squared. So I can substitute x squared in for f of x, and I get the equation x squared plus 3. The same thing here, I would get x squared minus 3. So what I want you to do is I want you to sketch these 3 graphs. I would probably start off with putting this one in my calculator, y equals x squared, and then I would put this one in and see what happens where this graph shows up on my calculator. Then I would do this one afterwards, but I would kind of do them one at a time and see what happens. So if we sketch these 2 graphs on the grid, y equals x squared plus 3 looks like that. And the y looks something like this. So let's look at the chart. The graph that's in green is my y equals x squared plus 3. That was my f of x plus 3. Where's the vertex of this graph in green? 0 and 3. Does this graph have a minimum point or a maximum point? So does it have the lowest possible point or the highest possible point? The lowest, which would make it a minimum. And the minimum value is whatever the y value is in the vertex. So it has a minimum of 3. Meaning that in this graph in green, I'm never going to have a y value that's equal to 1 or anything negative. The equation of the axis of symmetry is still through the y-axis, which is the equation of x equals 0. So to describe the transformation, you guys told me, Hannah said that we moved the graph 3 units up. Moving the graph up we call a translation. And if I go up or down, it's affecting my y values, which is vertical. So it becomes a vertical translation of 3 units up. Now if I look at the graph in red, I have y equals x squared minus 3. Where's the axis of symmetry in my red graph? Does this have a minimum point or a maximum point? It's a minimum again because it has a low point. The minimum this time would be equal to -3. The equation of the axis of symmetry and to describe the transformation, I can say that this becomes a vertical, because I'm moving up and down. So it's a vertical translation, 3 units down. So the last line uses a value of q. Instead of giving me a number, it says it could be q. Q could be any real number that I can think of. My equation from this function, where I see f of x, I substitute in x squared, so I would get x squared plus q. What is q doing to the graph? What did the 3 do to the graph? Moved it up or it moved it, what did the -3 do?
Oh, down.
Down. So the effect of the parameter q, so we're going to kind of do some of these questions while we fill in this row. So the effect of the parameter q is it causes the graph, or the graph has a transformation, or I guess maybe not transformation, let's say translation, or vertical translation, sorry. So that Q does a vertical translation of the graph of Q units. So when Q was +3, it went up. So if Q is -3, I go down 3. If Q was 10, what would I do with the graph? I'd go up 10. If Q was negative 2.6, I'd go down 2.6 units. So that is actually this part of the row. Vertical translation, Q units. And because it's a plus Q, it would be Q units up. How does my vertex compare to my equation? The y becomes the constant. So what would be my vertex in this last row? 0 and Q. How does the vertex relate to my minimum or my maximum value? Be a minimum of Q. And then my axis of symmetry is still at x equals 0 because I haven't moved it left or right, I've just moved it up or down. All three of these graphs point in which direction? Up. Graphs that point up have minimum values. Graphs that point down would have a maximum value because it would have a high point. Okay? So compared to the graph of y equals x squared, if I have the graph of y equals x squared plus q, I get a vertical translation or shift or slide of q units. When the value of q is greater than 0, so in other words when it's positive, what does the parabola do? It goes up. And when the value of q is negative, it moves down. Your homework is I want you to do investigation 2. So I'm going to start you off. Because this part in here, this is function notation. So the y equals f of x, which equals x squared. If x is equal to x plus 3, it means where I see an x in the equation, I substitute in an x plus 3. This becomes my equation. So if I have the equation y equals f of x minus 3, my equation would be x minus 3 squared. Because this means substitute x minus 3 in for x of this equation. So what you're going to do this time is you're going to graph these two graphs. Again, I would recommend start off with your y equals x squared and then graph your x plus 3 squared. Then do that information and then do your x minus 3 squared. Don't forget the brackets, they are very important. And this is where we'll start off next time. So yesterday we were looking at the graph of quadratics. So we started off with just our x squared, which is this parabola that opens up. So it opens upwards. The axis of symmetry goes through the y-axis. The vertex, which in this case is the lowest point on the graph, becomes a minimum value. That vertex is where the axis of symmetry intersects the parabola. And so that was our y equals x squared. And then what we looked at in investigation number 1 was what would happen if I add this constant value to the x squared? What does that constant do to the graph? And we discovered that it shifts the graph either up or down. So an x squared plus 3 moves the entire graph up 3 units. When it's minus 3, it moves the graph down 3 units. The other thing that we looked at was with the function notation. If y equals f of x, which is equal to x squared, f of x plus 3 would be x squared plus 3. I substitute in x squared wherever I see f of x. So the investigation that I had you working on last night was f of x plus 3. So where I see the x squared, where I see the x, I substitute in an x plus 3. What type of a graph did you get when you graphed x plus 3 squared? Where did the graph go?
On the negative side.
On the negative side. How many ways did, so which way did it shift? Up, down, left, right?
Left, 3 units.
And it's the exact same graph as the black one. It's just 3 units to the left. And the x minus 3 went where? 3 units to the right. And again, it is the exact same graph. It's just been shifted to the right. So let's fill in this chart, and then we're going to discuss this whole to the left and to the right business. So in the first one, my equation would be y equals x plus 3 all squared. Where is the vertex of this graph? Yep. Does this have a minimum or a maximum? A minimum. And what is the value of the minimum? 0. The value of the minimum is the y value of the vertex. What is the equation of the axis of symmetry?
X equals -0.
Right. So your axis of symmetry and your minimum or maximum value relate to the vertex. The x value is your axis of symmetry. The y value is that min or max point. And if I had to describe this transformation, it's a translation or a slide. Which way? Horizontally. So a horizontal translation, how many units? 3 to the left. So then if I look at the next row of f of x minus 3, which would be x minus 3 squared, what's the vertex this time?
3 and 0.
Min or max? Of what? And axis of symmetry?
X equals 3.
So I have a horizontal translation again. How many units?
3 units, right?
And with the last row looks at a generic p-value, where p could be anything. So if I have y equals f of x minus p, my equation would be x minus p squared. What would my vertex be? P and 0. Min or max?
Min
Of
0.
axis of symmetry.
X equals P.
And I have a horizontal translation again. Horizontal translation. How many units?
P units right.
To the right. So what effect does the parameter p have on the graph? What did p do to the graph?
It has a horizontal translation for P units.
Yeah, it's exactly what we have written right here. So horizontal translation. P units. Right. What if I wanted to go p units to the left, what would my equation look like?
Would be x plus p.
Yeah, so x plus p squared would be p units to the left. How many of you think that looks actually backwards?
I totally got
Yeah, it's totally backwards compared to what we did with q. When it was a plus q, it went up. When it was a minus q, it went down. So why is this different? Well, there were the two parameters that we've looked at. This one moved the graph up, and this one moved the graph to the right. Let's just look at x minus p on its own. 5x minus p, and I isolate x, I get that x equals a positive p. Positive p is to the right. If I went x plus p squared, that was the transformation that went to the left. I get x is a negative p. Does that help clear that part up? If I'm going up or down, what coordinate is being impacted? The x coordinate or the y coordinate? The y coordinate. So if I put q over with y, oops, this is what I get. This is the exact same equation. I've just moved the q to the other side. This moved it up. Why? Y equaled q. If I have x squared minus q, which I know moved the graph down, if I put it to the other side, I get a plus q and I get a negative. When the q is with the y, it does the same thing as when the p was with the x. It's the opposite. A plus went left, a minus went right. A minus goes up, a plus goes down. The reason why it looks clearer is because the q is never with the y. We always put the q to the other side because we always write our equations as a y equals. So they do actually have the same mapping. Actually, we don't call it mapping. They have the same replacements to them, and we'll look more at replacements next year when we start doing a lot more of these transformations. But what I want you to see is it is the same process. When the q is on the other side of the equation, y minus q still goes up. X minus p goes to the right. Y plus q goes down. X plus p goes left. It is the opposite of the way that we think about it. So think of what the value, this constant term, this p or this q value, where does it belong? And that will help start to get it more, I don't want to say clearer because it still is going to be confusing because our mind sees plus and we think up, we think to the right. And this goes the opposite of how we usually think. Okay. Compared to the graph of y equals x squared, the graph of x minus p squared results in a horizontal translation. When the value of p is greater than 0, the graph moves to the right. And we're talking about it's written in the form of x minus p. When p is less than 0, would make p negative. If I have x minus a negative p, what does that become? X plus p. The graph moves to the left. So my equation is always written in the form of x minus that p value. When it's x minus p, I move to the right. When it's x plus p, I have to remember that it was minus a negative. Okay? Now let's put them together. Consider the function f of x equals x squared. Write an equation which represents f of x plus 2 minus 4. So where I see x, I'm going to substitute in the x plus 2. And then I'm going to subtract 4 to that expression. And that will be the equation that I get. So if we take what we did before, what does this negative 4 do to the graph? What did the q value do to the graph? Does it go up or down or left and right? It goes up or down. So now it's a matter of remembering, does this go down or does it go up? It goes down, because remember when it's over here, it would have been a y plus 4 or a y minus negative 4. So that's the other way that you can think about it. It would have been a y plus 4 equal this, which y plus 4 is the same as y minus a negative 4. That negative 4 tells me to go down. This right here, this is the same as x minus negative 2. So this tells me that I would go down 4 units. And what does the 2 tell me to do? Go left 2 units. And usually we go left and right before we go up and down, because our left and right is our x's and our up and downs are our y's. X before y. So if I graph this, we have x plus 2 squared minus 4 Does it look like the graph went 4 units, or sorry, 2 units to the left and 4 units down? Yeah, especially if I let y2 be equal to x squared. This graph, if I slide it over to here, how did I do that? I went 2 to the left and I went 4 units down. So if we fill in this chart, I've got y equals x plus 2 squared minus 4. What is the vertex? Negative 2 and negative 4. Good. Does this have a minimum or a maximum? Minimum. And what's the minimum value? So the minimum value is negative 4. What's the axis of symmetry? X equals negative 2. And then the description of the transformation is this is a translation of 2 units left and 4 units down. So if we extend that algebraically to just have any value we call P and any value that we call Q, if I have the function y equals f of x minus p plus q, my equation becomes wherever I see an x, I substitute in an x minus p. So I get x minus p squared, and then the plus q. Because this is written as x minus p, the p value is going to the right, so I'm shifting p units right. And that plus q over on the other side was a minus q, which means I'm also going up. So with the p and the q, this is the way the equation is always supposed to be written. It's always supposed to be an x minus that value. So if it's x plus that value, rearrange it or think of it as an x minus the negative value. So x plus p squared originally would have been x minus a negative p squared. We just simplified it by combining the two negatives. This tells me to move to the left. This one's telling me to move to the right. The q value, because it's on the same side of the equation as the x, goes whichever way the sign is. A plus means I go up, a minus means I go down, because it was the reverse when it was over on the other side. So my vertex would be at P and Q. I'd have a minimum value of Q and an axis of symmetry where X would be equal to P. So class example number 1 just asks you to describe how the graph of the following functions relate to the graph of y equals x squared. So instead of having x squared, I have x plus 10. If I told you you had to write it as an x minus, what would that be? X minus what? X minus negative 10. Because it's with the x, it has to be a left or a right because my x's are on that horizontal axis. Am I moving left or right? Left, because this is a negative 10. So this is left 10 units. I won't expect you to write out all of the horizontal translation. It's implied if I tell you to move something 10 units to the left, it is a horizontal. With the second one, the x squared plus the 4. Does the 4 belong with the x or does it belong with the y? And how do I know?
The y.
Why does it?
Not in brackets with the x?
It's not in the brackets. If it would belong with the x, it'd be in those brackets and the squared would be to the outside. So this actually belonged over with the y. You can choose to do this one of two ways. You can put it over with the y, in which case you'd have a y minus 4 equals x squared. And then you have to remember, what does the minus, when it's written as y minus, is that an up or a down? It's the same as when it's an x minus. So x minus p went to the right, y minus q is going to go up. So this would be 4 units up, which actually related to the plus 4. So I don't necessarily need to put that plus 4 to the other side if I remember that the y and the x's are actually opposite to each other. It seems backwards, but it works. The last one. X minus 5. What does the 5 tell me to do? What about the 8? 8 units down. And I can see it's 8 units down in one of two ways. I could rewrite this y plus 8 as y minus negative 8 equals x minus 5 squared. Or I could go y equals x minus 5 squared minus 8 and move it to the other side. And again, that minus 8 is going to tell me to go down. In class example number 2, you're going to write the equation. So we start off with x squared. If I do a horizontal translation of 5 units to the right, is that an x or a y? It's an x. So I'll have y equals, and I'm going to open up a set of brackets, because that's how I'm going to put it with the x. How do I show 5 units to the right? And then it's squared. So now if I do a translation of 6 units down and 4 units left. So let's start with the x, the 4 units left. How do I show the 4 units left? X plus 4. How do I show the 6 units down? Minus 6 on this side of the equation. It would be a y plus 6 if it was on the other side. Okay. Last question. Write the coordinates of the image point 3 and 9 on the graph when a translation of 2 units up and 7 units to the right is applied. So I start off with the point 3 and 9. If I move 7 units to the right, where would I go? Where would I be at? I'd be at 10. So 7 to the right would put me at 10 and 9. And then if I move 2 units up, where would I go? 10 and 11. Okay, your questions that I want you to work on. Question number 1, A, C, and E, 3C and 4B. Question number 5, I want you to do the second and third column. And then 7, 9, and 10. Or do I want to do stuff? Yeah, 7, 9, and 10.